In this video, I'm going to solve these three problems taken from the book Principles of Physics, 10th edition. The title of the chapter is Coulomb's Law. First question. As a cat rubs its back along a carpet, it occurs a charge of plus 8.2 multiplied by 10 to the power of minus 7 Coulomb. How many electrons did it lose to the carpet? So, what is exactly given in the question? The cat came and it rubs its body to the carpet. By the time, what will happen? The cat body, the cat head is going to lose the electron. The carpet is going to gain the electron. So, what they are mentioning in the question, you have to find how many electrons the cat is losing. So, that is our question. So, for getting the value of the electron, number of electrons, we have to use the charge quantization formula. So what is the charge quantization formula? Net charge, which is equal to N multiplied by the elementary charge. So we are going to use this equation for getting the value of number of electrons. So if you want to use this, we have to rearrange this equation in terms of N. Therefore, N, which is equal to net charge over elementary charge. And here the net charge is 8.2 multiplied by 10 to the power of minus 7. So I'm going to substitute the value here. 8.2 multiplied by 10 to the power of minus 7 divided by the elementary charge value is 1.6 multiplied by 10 to the power of minus 19. So all the constants value will be given in your paper. So we have to find the answer right now. 8.2 multiplied by 10 to the power of minus 7 over 1.6 10 to the power of minus 19 gives 5.125 10 to the power of 12. 5.125 multiplied by 10 to the power of 12 electrons. So this many electrons the cat loses from its body. Clear? And the carpet gains this many electrons. Second question. What is given in the question? The magnitude of the electrostatic force between point charges Q1 26 microcoulomb and Q2 47 microcoulomb is initially 4.7 Newton. The separation is then changed such that the force magnitude is then 0.57 Newton. So better I will draw the diagram for this question. By that you will get the clear information. Clear? So you have two charges. Let's we take Q1 is here, Q2 is here. And these two charges are separate with the distance d. And by that time, how much force these two charges experience? It's experienced the force of 5.7 Newton. And then the separation changed. They did not mention how much it changed. But after you change the separation, after you change the distance, what happened to the force? You got the another value as 0.57. So now you have to compare the value of 0.57 to the value of 5.7. So initially you have a bigger number, but after you change the distance, how much the number you got, the force magnitude, it's 0.57. So how it's possible? Whether the distance is decreased or increased. When you just see the value of the force, the second part, after you change the distance, its value decreases. So generally, the force value get decreases when the distance will increase. So if you see the diagram, Q1 is here. And what is the Q2? Let's we take here. Now, what happened to the distance? The distance increased. So whenever the distance get increased, the magnitude of the force will decrease. So for that purpose only we got the answer of the second part. Force is 0.57 Newton. Clear? So we don't know what is the distance. So better I can take the first part as R1. We don't know. Likewise, for the second part, after you change the separation, we don't know what is the distance. But we have the value of charges Q1 and Q2 as 26 microcoulomb and 47 microcoulomb. Now we have to find two answers. So because this question has two subdivision, in the first subdivision, we are going to find the value of ratio of the new separation to the initial separation. What is the new separation here? The new separation is R2, because if you read the second line, the separation is then changed. That means the new separation here is nothing but R2. What is the old separation? The initial separation, R1. So they are asking about what is the ratio. We have to find this value. In the second part of the question, we are going to find what is the value of the new separation. That means we are going to find the value of R2 alone itself. For this, we have to use the Coulomb's law for each cases. So first I'm going to apply the Coulomb's law for this case, and then I'm going to apply the Coulomb's law for this case. So better I'm going to frame the equation here. What is Coulomb's law? F1, because we have two different diagrams, so I'm going to take F1, this one, and F2 here. Okay, so F1, I'm going to apply the Coulomb's law for this case. What is the case? K multiplied by magnitude of Q1 multiplied by magnitude of Q2 divided by R1 square. So I'm going to frame the equation for this also. F2, which is equal to K magnitude of Q1 magnitude of Q2 over R2 square. Now I'm going to substitute the value here. F1 value is given in the first part as 5.7 Newton, and K value is a constant 8.99 multiplied by 10 to the power of 9, and the magnitude of the first charge is 26 microcoulomb and 47 microcoulomb. 26 microcoulomb. 26 multiplied by 10 to the power of minus 6 multiplied by 47 microcoulomb. 47 multiplied by 10 to the power of minus 6 divided by R1 square, because we don't know that value. Likewise, you have to write the equation. Write the equation. You have to substitute the value in this equation. So here F2 is 0.57. 0.57. Better I can take this as equation 1. So after I substitute the value in the second equation, the second force is 0.57, which is equal to 8.99 multiplied by 10 to the power of 9 multiplied by 26 microcoulomb. 10 to the power of micro here stands for 10 to the power of minus 6. And then the second charge magnitude is 47 microcoulomb divided by R2 square. So I'm going to give the number of the equation as second. So now in the first part, we are going to find the ratio. So for that, what I'm going to do, I'm going to divide the equation. Either 1 divided by 2 or 2 divided by 1. So what I'm going to do, I'm going to divide 1 divided by 2. 1 divided by 2. So let's see what's the answer. So divide equation 1 or divide equation 1 by 2. Both the left hand side and the right hand side. So what you will get in the left hand side? 5.7 over 0.57, which is equal to this value divided by this value. Am I right? So I'm going to write 8.99 multiplied by 10 to the power of 9 multiplied by 26 multiplied by 10 to the power of minus 6 multiplied by 47 multiplied by 10 to the power of minus 6 divided by R1 square. Likewise, this part 8.99 multiplied by 10 to the power of 9 multiplied by 26 10 to the power of minus 6 multiplied by 47 multiplied by 10 to the power of minus 6. So what will happen? And divided by R2 square. Am I right? So when you divide this in the right hand side, what will happen? All these values get cancelled with this value. Am I right? So your equation will become as 5.7 over 0.57, which is equal to R2 square over R1 square. When you just make the multiplication, this will go to the numerator. Am I right? And here we got the relation as R2 square over R1 square, which is equal to 5.7 over 0.57, which gives the answer of 10. Am I right? But we need the ratio of R2 over R1, the ratio of new separation to the initial separation. So here R2 is the new separation and R1 is the initial separation. So we have to take the square root on both sides. When you take the square root on the left hand side, R2 square over R1 square will give as R2 over R1, which is equal to square root of 10, which is exactly equal to R2 over R1. Sorry, R2 over R1. So better I will write here. So R2 over R1, which is equal to 3.16. What's the value of square root of 10? The value of square root of 10 is 3.162. That's it. There is no unit. Clear? So this is the answer for the first part. But here we have to find the second part also. What is the value of the second part? We have to find what is the value of new separation. So for this, I'm going to use the second equation. What is our second equation? Our second equation is this. So I'm going to find the answer for the second part. So for second part, I'm going to use second equation. I'm going to rearrange the second equation. So I have to bring this R2 square to the left hand side of the numerator, and I have to take this 0.57 to the right hand side of the denominator. By that, the equation becomes R2 square, which is equal to 8.99 multiplied by 10 to the power of 9 multiplied by 26 multiplied by 10 to the power of minus 6 multiplied by 47 multiplied by 10 to the power of minus 6 divided by 0.57. Clear? Now get the value. What is the value of R2 square? The value of R2 square, which is equal to, take your calculator, find the value, 8.99, 10 to the power of 9, multiply by 26, 10 to the power of minus 6, multiply by 47, 10 to the power of minus 6, divided by 0.57. So the answer here I got as 19.27. Actually, this is not 9 because it's a micro. Am I right? So the answer I got is 19.27. So we have to find the new separation value. So take square root on both sides. Therefore, R2, which is equal to square root of 27. When you take the square root, this becomes R2. So the value of root 19.27, which is equal to 4.39. What's the value? The new separation, which is 4.39 meter. Clear? So this is the answer for the second question. So here in the first part and the second part, we are just dealing with the Coulomb's law. But the most important thing, you have to identify what is the force in the first part, what is the force in the second part. Clear? Okay, now we have to find the answer for the third question. So what is given the third question? The magnitude of the electrostatic force between two identical ions that are separated by a distance 10 to the power of minus 10 meter is 9.25 multiplied by 10 to the power of minus 10. That means you have two identical. So the two ends have the same charge value. So better I'm just taking Q1, which is equal to Q2, which is equal to Q, because they mentioned two identical ions. And these two are separated by a distance. What's the distance? R value. What's the value of R? 10 multiplied by 10 to the power of minus 10 meter. For this distance, how much force it experienced? F, which is equal to 9.25 multiplied by 10 to the power of minus 10 Newton. Clear? So you have two parts. No, this question has three subdivisions. In the first part, we are going to find what should be the value of the charge. So we are going to find the value of the charge. So for this, we have to again play with Coulomb's law. What is our Coulomb's law? F, which is equal to K magnitude of Q1 magnitude of Q2, because Q1 and Q2 are exactly same, so we took as Q, so magnitude of Q, so which is divided by R square. Am I right? So what's the value of R? So better I will write the formula first and then I will substitute the value. So here we are going to find the value of the charge. So F, which is equal to K Q square over R square, and we are going to find the value of the charge. So please rearrange this equation in terms of charge. Therefore, charge square, which is equal to F multiplied by R square divided by K. Clear? Now I have to take the square root on both sides. So by that the equation becomes square root of F multiplied by R square over K. Substitute the value. What is the force? The force here is 9.25 10 to the power of minus 10 square root of 9.25 multiplied by 10 to the power of minus 10 multiplied by, what is the R? The R value is 10 multiplied by 10 to the power of minus 10. 10 multiplied by 10 to the power of minus 10, the whole square, divided by the Coulomb constant, 8.99 multiplied by 10 to the power of plus 9. So now we are going to get the answer for the charge, which is the answer for the first question. So square root of 9.25 10 to the power of minus 10. I am sorry again. I just made a mistake. This is 10 to the power of minus 10. 10 to the power of minus 10 multiplied by 10 multiplied by 10 to the power of minus 10 the whole square divided by 8.99 10 to the power of 9. I got the answer as 3.207. So I will round the value as 3.21 multiplied by 10 to the power of minus 19. Minus 19 Coulomb. So this is the answer for the first part. Clear? Okay. Now we have to see the second part. What is given in the second part? How many electrons are missing from the ions? So if you have this type of questions, immediately you have to write the formula for charge quantization. So net charge, which is equal to N multiplied by E. Therefore, N, which is equal to net charge over elementary charge. What is our net charge here? The answer what we got in the first part. So better if you have a doubt, you can just write as a small q. Clear? Clear? So if you want, I can write it again. Q net, which is equal to N multiplied by E. Therefore, N, which is equal to Q over E. The answer for this Q, we have to take it from the first part. So what is the answer in the first part? 3.21 multiplied by 10 to the power of minus 19. 3.21 multiplied by 10 to the power of minus 19 divided by the charge, elementary charge value is 1.6 multiplied by 10 to the power of minus 19. You will get the number of electrons missing. How many electrons are missing? 3.21 10 to the power of minus 19 divided by 1.6 10 to the power of minus 19 gives the answer of 2 electrons. 2 electrons missing. Clear? So this is the answer for the second part. In the third part of the question, what is the force magnitude if the separation is half? That means between the two charges there is a distance, am I right? So now what they said, suppose if the distance between the two charges are half, what will be happen? So you have to find the value of force. For getting the third answer, if the separation is half, that means r over 2. Am I right? Half means the distance we mentioned as r, but what is half of the distance? R over 2. So we are going to write the Coulomb's law again, F which is equal to K Q magnitude, because two are identical charge, over R over 2. Why? Because the distance get half, the whole square. Now we have to substitute the value. So what will happen? So when you're squaring this number, in the denominator you will get 4. That 4 will go to the numerator. So by that your equation becomes 4k q square over r square. Clear? Now substitute the value. F is equal to 4 multiplied by 8.99 multiplied by 10 to the power of 9, and the charge value we got in the first part is 3.21 10 to the power of minus 19. 3.21 multiplied by 10 to the power of minus 19 square over the distance r is 10 multiplied by 10 to the power of minus 10 the whole square. F which is equal to 4 multiplied by 8.99 10 to the power of 9 multiplied by 3.21 10 to the power of minus 19 square divided by 10 multiplied by 10 to the power of minus 10 square 4 multiplied by 8.99 10 to the power of 9 multiplied by 3.21 10 to the power of minus 19 square divided by 10 multiplied by 10 power minus 10 the whole square. I got the value as 3.70. 3.71 multiplied by 10 to the power of minus 9 Newton. Clear? So this is the answer for the third part. This is Newton. Clear? Understand? So in this chapter, we have only two important formula. One is Coulomb's law, and the second one is the charge quantization. Clear? That's it. Thank you.